Hello everyone and welcome to the second lecture of Infinity Learning. I am your friend AbhishekGupta and I am going to continue the subject information theory and coding, and today I am going to start with the topic average mutual information. So I have skipped the formula of information in the previous lecture, so I incorporated that formula here. So you can see that information is denoted by Ix and is equal to log base 2 of 1 by px, where px is the probability of the random variable x. So we can also write it as minus of log of px base 2. You all know the property, this property of logarithm, so I don't need to explain it. So before knowing average mutual information, we need to know what is mutual information. So mutual information can be denoted as I of xi comma yj, which is equal to log of p xi by yj divided by pxi whole base 2. So this is the mutual information formula. We need it for the calculation of average mutual information. Okay, so what is average mutual information? Now average mutual information of two random variables is the average measure of the mutual dependence between the two variables. So it is nothing but the average measure of the information, the dependency between the two random variables, for example say x and y. So it can be represented by a Venn diagram. We can see that we have two random variables x and y. X has the information ix and y has information iy. So we can see that there is a common region as they are overlapping. So this common region can be represented as x intersection y, which has the information capital I of capital X comma capital Y. So this I of x and y is nothing but the average mutual information, as it is mutual to both the variables x and y. So the average mutual information ixy can be formulated, so it can be further simplified as summation over I up to n and summation over j up to m p of xi comma yj into log of pxi comma yj by pxi into pyj whole base 2. So it is nothing but actually the. So the next topic is entropy. Like we have studied entropy in different subjects and it has also some kind of reference to it. Like generally we can define entropy as the measure of uncertainty of a variable or an event. So it is can be basically defined as it is a basic quantity associated to any random variable, say x, which can be interpreted as the average level of information, surprise or uncertainty inherent in the variable's possible outcomes. Now many of the students or people get confused between self information and entropy, as they are very much identical to each other, but there is a thin line of difference between them. Self information is that information which is associated with one particular outcome or event of a random variable. So it is associated to one and only one particular outcome of the random variable. Entropy qualifies how informative or surprising the entire random variable is, and it depends on all its possible outcomes average. So it is not based on a single particular outcome, but it is based on the average of all. Now we can give the formula of entropy as H is equal to summation over j pj into log of 1 by pj base 2. So this H will represent entropy. Now we can simplify this formula as we know the properties of logarithm. So summation over j pj log of pj base 2. So this is the simplified version of the entropy formula. Now entropy can be of two types. First one is joint entropy and the second one is conditional entropy. Now joint entropy is represented or is denoted in this way. h of x comma y. But conditional entropy, just like the conditional probability format, it is so joint entropy have the formula h of x comma y is equal to minus of summation over I summation over j p of xi comma yj into log of p of xi comma y. As it is joint entropy, the probability portion in the logarithmic part is also in the format of joint probability. Similarly, the conditional entropy have the probability part as the conditional probability of the logarithmic value. So h of y by x is equal to minus of summation over I summation over j p of log of p of yj by xi base 2. So we can simply observe that the probability in the logarithmic part defines the entropy. Here it is the joint probability, so it is for joint entropy, and here it is the conditional probability, so it is. Now how can we define both these types of entropy? We can simply define them as this. Joint entropy is the measure of how much entropy is contained in a joint system of the two. It is nothing but the amount of entropy which is contained in the joint system of the random variables. But conditional probability quantifies the amount of information needed to describe the outcome of one random variable given the value of other variable. So on the other hand, conditional entropy is the amount of information which is required to describe the outcome of first random variable if and only if when the value of the second variable is provided. So as we discussed about the entropy, let us solve a problem on entropy. So the question says that suppose a DMS produces 4 symbols x1, x2, x3, x4 with probabilities 0.5, 0.2, 0.2, 0.1 respectively. We need to determine the entropy. So what is DMS? So it is applicable for discrete signals only, and memoryless means it has no previous values or no previous memory, and it is a source, so it produces symbols. So we are required to find the entropy. We know entropy is equal to minus summation over j pj log of pj base 2. Now here j is from 1 to 4 as x1 from x4 to x4. So this will be pj log pj base 2. So this will be written as minus p1 log p1 base 2 minus p2 log p2 base 2 minus p3 log p3 base 2 minus p4 log p4 base 2. Now we need to directly put the values of p. So this will be minus 0.5 into log of 0.5 base 2 minus 0.2 into log of 0.2 base 2 minus 0.2 into log of 0.2 base 2, and this will be 0.1 into log. So it will come up to be plus 0.5, and this will be plus 0.464, and this will be the same plus 0.464, plus this will come 0.332, and after adding it will become 1.76. So the unit is also important for entropy, and so the unit of entropy is bits per symbol. We need to memorize it because we will need it. The unit of entropy is bits per symbol. So the answer will be 1.76 bits per symbol. So the next topic is the information measures for continuous random variables. Here we will define the different definitions that we defined for the discrete random variables but for the continuous random variables, and how we can do that. So the definitions for discrete random variables can be directly extended to continuous random variables by converting the summation into integration. So we can simply convert the definitions for the discrete random variables into the continuous random variables by simply converting the summation into the integration form. So I have built a table of the measures and the discrete and the continuous formula. So the first measure is average mutual information. So for the discrete one, it has a formula summation of I up to n summation over j up to m p of xi comma yj into log of p of xi comma yj divided by pxi into pyj base 2. So this is for the discrete one, but for the continuous one, here we can see that the summation has been converted into the integrals and the limit is from minus infinity to plus infinity, and after that there is px into p of y by x into log of p of y by x into px by px into py base 2 dx dy. So it is almost same for both the cases. In the second measure, that is the entropy, the discrete one has a formula minus of summation over j pj log of pj base 2, and for the continuous one it has minus integration of minus infinity to plus infinity px log of p dx. So you can see that both the formula are same except for the summation and the integrations. And the last one is the conditional entropy. For conditional entropy, the discrete formula is minus of summation over I summation over j p of xi comma yj into log of p yj by xi base 2. Similarly, for the continuous one, if we convert the summation into integration, the whole thing will remain same. So it will be minus of double integration minus infinity to plus infinity limit p of x log of p of yj by xi base 2 dx dy. So from the given table you can observe that for around every measure the discrete and the continuous formulas are almost same, but the summation discrete form is converted into the integral continuous form. So the last topic for the today's session is the source coding theorem. So before knowing the theorem, we need to know what is source coding. Source coding is the mapping from a sequence of symbols from an information source to a sequence of alphabet symbols that are usually bits, such that the source symbols can be easily exactly recovered from the binary bits or within some distortion. So source coding is the mapping of the sequence of symbols for an information source to bits in such a way, in such a fashion that it can be exactly recovered or it can be recovered with some little distortions, with some acceptable amount of distortion. So it states that n random variables, each with entropy hx, can be compressed into more than n into hx bits with negligible risk of information loss as n tends to infinity. But conversely, if they are compressed into fewer than n hx bits, it is virtually certain that the information will be lost. So it basically means that suppose there are n number of random variables, each has entropy hx, so we are required to compress it in such a rate which will be more than nh bits, and it will have negligible risk of information loss because the number of random variables will be very high. But if they are compressed at such a rate which is lower than nh bits, so there is chance of information loss. So if we need the information to be distortionless, we have to compress at a rate greater than nh, or else the information will be lost or distorted. So it will give a condition like n naught will be greater than nhx, where n naught is the compression factor. Not the compression factor. So that's the basic of the source coding theorem. This source coding theorem is also known as the Shannon's coding theorem because it was proposed by the famous scientist Shannon. So hope you guys like the video. If you do like it, please give it a thumbs up and share to your friends so they can clear their queries too. And if you have any doubts, you can write it in the comment section. I will try to answer them. And if you want more this kind of videos, please subscribe to the channel. I will try to bring up more and more interesting concept, more and more concepts in the industry interesting way. So for today, this is it, and I hope we will meet again in the next video. Thank you.